All right, next, I want to go through a list of questions. As actually, there's 38 questions I'm trying to cover that give you various different types of questions so that you have a more of a solid understanding when you deal with numerical questions. For example, what is the integral or indefinite integral of x to the power of 99 dx? Then you will have to raise the power from 99 to 100, but you want to divide it by 100 plus c, so that when you're going backward, taking the derivative of this, derivative of c is going to be 0, derivative of 100, x to the power of 100 is going to be 100, x to the power of 99, and 100 cancel, so that you go backward to integral of x to the power of 99. Question number 2, what is the integral of x to the power of 0.01? And very similarly, this is going to be increasing the power by 1, so that I get 1.01, and divided by that divided by whatever the coefficient you're getting, 1.01, then plus c. Then number 3, what is the integral of x to the power of negative 99? And that will give you, you want have x to the power of the power that from negative 99 plus 1, that will give you negative 98. And also you want to divide it by the coefficient so that it will be cancelled out and divided by negative 98 plus c. You always want to have this plus c because this is an indefinite integral. And number 4 is, what is the integral x to the power of negative 0.01 dx? And that will be x to the power of negative 0.01 plus 1. That will give you positive 0.99. Then divided by the coefficient, then plus c. So far, it's really just using the power rule for the definite integral, or it's more like a power rule backward for the derivatives. Number 5, what is the integral of 5 dx? We know that the derivative of 5x will give you 5. Therefore, integral of 5 is actually going to give you 5x. It's more of this is x to the power of 0, and the increase 0 to 1, therefore, it's a 5x to the power of 1. Don't forget plus c. Number 6, and what is the integral of just the dx? If there's just the dx, is actually there's the invisible 1 in there, and that will give you just the x plus c, because the derivative of x is a 1. It's almost like as they didn't put that in there, but that's the invisible 1. 7, what is the integral of 5 over y to the third dy? Now, if you notice, this is all dx. That represents the variable you're having is x, and I'm taking derivative with respect to x. Now, this becomes a y, and the variable is y. I can give you another example if it's not that case. So for this one, it's integral. I'm going to change my question into a y to the power 3 so that I can use the power rule. Otherwise, it's a fraction. It might be a little hard to think through. So this is going to be 5, and y to the power of, because this is going to be increasing by 1. When you take a derivative, decrease by 1. When you take an integral, it's increased by 1. Therefore, becomes negative 2. Then you want to divide it by that coefficient, and making sure I have a plus c. And if you write this nicely, I'll simplify it. You get a negative 5 over 2, 1 over y squared plus c. Now, I'm going to create a similar question. This is a question come from the back of the textbook that when you have, what if this is integral 5 over y to the third dx? Now, the variable is y, but you're integrating with respect to another variable. Therefore, for the variable of x, y is a constant. Therefore, this becomes y over 5 over y squared times x plus c. Now, it's really just testing your understanding, making sure you understand that what is the variable you're doing. So, for example, when you take a derivative for this, x is your variable. This is a constant number. Therefore, you want to, the derivative of this is simply 5 over y to the cube. question number 8. It will be, the question is integral 1 over 2 y to the 5th dy. And I'm going to convert it such that it is integral 1 over 2 y to the negative 5 dy. And the answer will be, you want to keep this 1 over 2. This is more like the multiply a constant rule for the indefinite integral we talked about in the previous lecture. Then you want to just multiply this in the end. And this is y to the negative 5. Now this is how you want to increase by 1. So it becomes negative 4, also divided by 1 over negative 4. Then making sure I have a plus c. You can rewrite this or simplify it that it's negative 1 over 8 y to the negative 4 plus c. Or you can also write it 1 over 8 y to the power of 4 plus c. Okay, number 9. And question is integral. I have it here. Number 9 is you have integral y to the power of 3 over 2 over square root of 2 dy. And this is square root of 2 is a constant value. Therefore, it's 1 over square root of 2 y to the 3 over 2 integral dy. That's the question you're trying to work with. Therefore, it's 1 over square root of 2 y to the power of, now you want to increase by 1, 3 halves add up by 1, it will be 5 halves. Then making sure divided by 1 over 5 halves and a plus c. And the further step, you want to simplify this. 1 over 5 over half, that is when you divide it by a fraction, the same thing as multiply its reciprocal. That is the same thing as 2 over 5 and a y to the power of 5 over 2 plus c. Or this is going to be 2 over 5 times root 2 y over 5 over 2 plus c. Okay, number 10. And integral pi and y to the power of 2 over 3 and dy. And that will give you, pi for this case is going to be a constant. You just need to integrate y to the power of 2 over 3. Therefore, this is the pi multiply y to the power of, you want to add a 1, that will give you 5 over 3. And this is 1 over 5 over 3 plus c. Real quick, it will be 2 over 3 plus 1. You want to have a common denominator. It will be 2 over 3 plus 3 over 3, and you're getting 5 over 3 for this case. That's what you get from here. Okay. Then you can simplify this. Divided by a fraction, same thing as multiplies a reciprocal. Therefore, it's a 3 over 5 times the pi, and y to the power 5 over 3 plus c. Okay, I'll do the next 10 questions in the next video.